Miss Conman, you gonna go open the windows? All right, ladies and gentlemen, that's enough. Shh. So I know this is blurry, but this is y equals x minus 1. Is that in slope-intercept form? Yes. Okay, let's look at the next one. We've got 2x minus y equals 4. That is not in slope-intercept form. What is my first step going to be? Yes, Jasmine? Subtract 2x from both sides, and we're going to end up with negative y equals negative 2x plus 4. Am I finished? Is it in slope-intercept form? No. What do I have to do? Divide everything by negative 1. Thank you, Tristan. We divide everything by negative 1, and we end up with y equals 2x minus 4. So I'm going to graph my first one right here that was already in it in black. So first I'm going to put a dot at negative 1, because that is my what? Negative 1 is the, not slope, but the y-intercept. And now my slope is 1. So I go up 1 over 1, up 1 over 1. I'm going to do it all the way up the graph, and I'm going to do it all the way down. And I've got a nice straight line. The next one I'm going to do in blue, and where am I going to put my first dot on my graph? For this bottom one right here. Yes, Tristan? Negative 4. So I go down 1, 2, 3, 4, and I put my first dot. What is my slope? Good, Demers. Up 2 over 1. We go up 1, 2 over 1. Up 1, 2 over 1. Up 1, 2 over 1. And we can keep going. But the whole point is that it crossed right here at 3, 2. Positive 3, positive 2. That is my answer.
You guys see where it crossed? Any questions?
Okay. Now we're going to do this same problem, but we are going to do it by substitution. So if you will move down. There we go. We're going to move down to example 2. Do you see this problem? It's the exact same problem that we did for graphing, but now we're going to use substitution to do it. So all I'm going to do is substitute it in. I'm going to take x plus 1 right there, that x minus 1, y equals that. Everybody agrees that y equals x minus 1? So I'm going to take this and I'm going to plug it in where there's y. So now I get 2x minus x minus 1 equals 4.
You guys see where she got that from?
All I did was take out the y and I substituted in what y is equal to. What is on the outside of my parentheses? Before the 2x, we have a negative. So I'm going to distribute this negative. So I get 2x minus x plus 1 equals 4. 2x minus x is how much? I have 2 x's, I take 1 away. How many do I have? So I get 1x plus 1 equals 4. Subtract 1 from each side, and I get x equals 3. 1x and x are the same thing, right? So I could divide by 1, but I'd still end up with 3. So now I have the x value. Now I'm going to take this little 3, and I'm going to plug it back into this original problem up here. So I get y equals 3 minus 1. What's 3 minus 1? 2. So y equals 2. So my answer is, put the x first, which is 3, the y second. Do you see how those two match?
If they match, you did it right.
Because
if they don't match, you did something wrong.
Graphed the two lines and found out where they intersected. And now we solved by substitution and found out that we got the same answer.
Jasmine, are they going to give you the substitution problem?
For the book, they're not going to give you a graph. They're just going to have you solve it by substitution. So you know how the first part, we put it in y equals mx plus b form, graph the two lines, found out where they're intersected? You won't have to do that part. You'll only have to do this part.
Now you'll have to do both on the quiz. You'll have to solve some by graphing.
And some by substitution. But it'll say the words solved by substitution or the words solved by graph. No, you won't know what the answer is.
You'll find the answer once you graph the lines, right?
Or you'll find the answer by doing substitution.
That's how we just found it.
What's your question, Jasmine? I'm confused. Are you asking me if I'm going to give you these two lines and tell you what the point is?
No, I'm asking if, like, are you going to give, like, the X and the Y and then so
No.
check?
No. This is not a check. This is just showing that if you do it either way, you get the same answer. Yes, Josh? Okay. Y equals, that's a very good question. Do you see this equation here? Y equals x minus 1. Do you see how I have x equals 3 here? So I took that 3 and I plugged it back in for x, which gave me y equals 3 minus 1.
Whenever you get a variable alone, like in this case, we solved for y. We substituted y in first, right? That means that whenever you put y in, you're going to substitute y in, you're going to get x. You're going to solve for x. And now you have to have an x and a y. So then we have x, you're going to plug it back into one of the two, and then you'll get y. Sometimes you might get x alone first. X equals blah, blah, blah. And then you solve, and you'll get the y.
We're going to try the second problem. We're not going to do the graphing at all. We're just going to do the substitution. So I'm looking at part B, for example 2. We've got 4x plus 3, y equals 3. And I've got negative 3x plus y equals negative 2. Is everybody with me?
Just when you go to substitute it in, like if you're substituting for X or Y, you just have to call it when you do the substitution.
All right, so we're going to look at these. Which equation has a letter that's all by itself with no number being multiplied by it? The blue one or the black one has a letter with no number in front of one of the letters. The black one. Which letter is by itself? Okay, so we're going to get y by itself because it's easiest. So I'm going to add 3x to both sides. And I get y equals 3x minus 2.
So always look for the variable that's alone. That means you only have to do one step, add or subtract to get it alone.
Okay. Now I'm going to take what y is and I'm going to plug it into this y up here. So I rewrite. Hold on 1 second. So what I'm going to do is I'm going to rewrite this top part, this blue part. But instead of writing the y, I plug in 3x minus 2.
You guys up there?
So we got a letter by itself. And then whatever that letter was, in this case y, we went to the first equation and plugged in what y was equal to.
That's why it's called substitution. Substitute one thing for another.
Like when you have a substitute teacher. Pulled me out, put Miss Davis in. Yes, right. Substituted in. That is, okay, she was no solution, that's fine. All right. So now I'm going to solve this equation. What do I have to do first? Distribute. Good. So I'm going to distribute this right here. So I get 4x plus 9x minus 6 equals 3. What can I do next? Put the x's together. 9 plus 4, 9, 10, 11, 12, 13. So I get 13x minus 6 equals 3.
Now what did you
Good. Add 6 to both sides. X equals 6, 7, 8, 9. And we divide both sides by 13, and I'm going to make this a decimal to make life easier. And 9 divided by 13 gives us, we'll round it to 0.69. So that is my x value. I have an x. What else do I need? A y. So I look back up at my original equation. 4x plus 3y equals 3. And so I plug that in. I've got 4 plus 3y equals 3. And I put the 0.69 in for where x is. And water now dripping on me. Yes. 4 times 0.69 is 2.67. Plus 3y equals 3. No, I don't want a different window because I want them to see it from the beginning to the end when I do it. And it's not run off that computer anyways, it's run off my laptop. Okay. So, I'm now going to subtract 2.67 from both sides. I'm left with 3y equals 3 minus 2.67. I get 0.33. Divide that by 3. And y equals 0.11. So my final answer, and you always put this in some sort of square indicating it, is 0.69, comma 0.11. This is my question. I know this takes a long time, but how hard would it be to graph 0.69 and 0.11? It wouldn't be possible. You would probably not get an accurate answer. Okay, we're going to try some more. All right, is everybody on the back? Did you guys talk about this yesterday? We're going to classify systems by consistent or inconsistent. Consistent means it has a solution. Inconsistent means it doesn't. And then you're going to classify it as independent or dependent. So you might want to write these down. Ready? Consistent, independent. Looks like an X and it has one solution. So we've got consistent, please don't whistle. Independent, looks like an X, one solution. Okay? And then we've got consistent, dependent, which looks like two overlapping lines. I call it the genie, because if each of my lines align, they overlap each other, look like a genie. Consistent, dependent. It has infinite solutions. Remember we talked about infinite before. And then we've got inconsistent, which looks like two parallel lines.